Hello students, welcome to Eshwari Tanisha channel. Students, in this video we are going to learn second important concept in this chapter, that is hybridization of carbon. The first concept what we studied was how to find sigma bond and pi bond in a given molecule. So students, last video if you have not watched, you can watch, it will be given in the playlist. So now coming to hybridization of the carbon. So how the question will be asked in the NEET examination. So here you can see NEET 2009. The state of hybridization of C2, C3, C5, C6. A molecule is given. In that you have to find the hybridization of carbon 2, carbon 3, carbon 5 and carbon 6. So here you can see 4 options are given. So question will be asked like this. So how to solve this? So we will solve this at the end of the video. So now coming to hybridization of the carbon. So students, what is the symbol of carbon? So it is C, and how many electrons will be there? There will be 6 electrons. How to write the electronic configuration for this? You will be writing 1s2, 2s2, 2p2. This is the electronic configuration. Now 2s2 and 2p2, this is the outermost orbital, so which will be involved in hybridization. So now as a result, carbon can show 3 types of hybridization. That is, it can show sp hybridization, sp2 hybridization, and then sp3 hybridization. So if you ask the question whether it shows sp3d2 hybridization, the answer is no, because there is no d orbital here. So students, how many orbitals are present here? One s orbital is there and one p orbital. Totally 1 plus 1, there are 2 orbitals which is involved in hybridization. Here 1 s orbital and 2 p orbital. So totally 1 plus 2, it will be 3. Here 1 s orbital and 3 p orbital, it will be 1 plus 3, which will be equal to 4. So now let us draw important table in which we will be writing some important concepts. So I'll tell you what you have to write. So first write sp hybridization, sp2 hybridization, sp3 hybridization. So students, if you know this, some of the important concepts you can understand. So what are they? So first what you can find out is S character. Second, bond strength. Bond strength. Next, bond length. Next is electronegativity. Electronegativity. So if you find out hybridization, so you can easily find out all this. So let us see how. So now in sp hybridization, how much is S character? So here you can see S and P is in the ratio 1:1. So S character will be 50%. Here 1:2 ratio, therefore S character will be 33.33%. And sp3, here S character will be 25%. So students, here S character, if it is more, so S character, so more the S character, bond strength will be more. So bond strength, so I'll write in short form, bond strength will be more. So more the bond strength, bond length will be short. So bond length will be short. So I'll write symbol downwards, which means it will be less. Bond length will be less. And then electronegativity. So higher the higher the S character, electronegativity also will be more. So this is the relation you have to understand. So now more the S character, bond strength will be more. So here where there is S character more, S character is more in sp hybridization. Therefore here the bond strength will be more. And here only 25% of S character. Therefore bond strength for sp3 hybridization it will be less. And here it will be intermediate. So coming to bond length. So what is happening to bond length? More the bond strength, less will be the length of the bond. So more the strength of the bond length will become short. Here it will become long. And here again it will become intermediate. So this will be intermediate. So coming to electronegativity, more the S character, more will be electronegativity of that atom. So here S character is more for sp hybridization. Therefore electronegativity will be more here, and here it will be less. So again this will be intermediate. So sp2 hybridization, everywhere you have to write intermediate, intermediate, intermediate. So this is the relationship you should remember. So if you know hybridization, you can write all this: bond strength, bond length, and electronegativity. So now how to find hybridization if a molecule is given. So we have a simple formula which you will be using to find the hybridization. So what is that? Hybridization is equal to number of sigma bonds plus lone pair of electron. Lone pair of electrons. So this is the formula you will use to find hybridization. So now if you get hybridization value as 4, so if the value of hybridization is 4, so then it will be sp3 hybridization. If it is 3, then it will be sp2 hybridization, and if it is 2, it will be sp hybridization. So how? We will take one example and we will understand. So suppose methane molecule is given. CH4 is methane molecule. So you can write this as carbon, hydrogen, 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 and hydrogen. So now how to find hybridization of this carbon? So you will write hybridization is equal to hybridization is equal to number of sigma bonds. How many sigma bonds are present here? 1, 2, 3, 4. So there are 4 sigma bond plus lone pair of electron. So students, carbon will not have lone pair of electron. Therefore you will write it as 0. So 4 plus 0 is 4. So if you are getting 4 as the answer, so it will be sp3 hybridization. Same way, if you get 3 as the answer, it will be sp2 hybridization. Similarly, if you get 2 as the answer, it will be sp hybridization. So now we will take some example and we will solve. So students, this is the first example, which is ethene. That is CH2 double bond CH2. So students, first we will write here, if hybridization is 4, it will be sp3 hybridization. If it is 3, sp2. If it is 2, then it is sp hybridization. So this is what we have to remember. So now see how many sigma bonds are present. So here you have one carbon and 2 hydrogen atom, carbon hydrogen atom. So totally how many sigma bonds are present? So to this carbon, 1 sigma bond, and here 2 hydrogens, therefore 3 sigma bonds are present. So hybridization of this carbon is, if 3 sigma bonds are present, hybridization is sp2. So this carbon is sp2 hybridization. So this carbon will show sp2 hybridization. Same way, this carbon also will show sp2 hybridization. Why? Because 2 hydrogen atom means 2 sigma bond and here 1 sigma bond. So totally 3 sigma bonds. So therefore it is sp2 hybridization. Second example. So here to this carbon we have to find hybridization. So here if two double bonds are present, one will be sigma bond and one will be pi bond. So 1 sigma bond plus 2 hydrogen atom means 2 sigma bond. 2 plus 1 will be 3. So totally 3 sigma bonds. So 3 sigma bond means this will be showing sp2 hybridization. This carbon 1 sigma bond, 2 sigma bond and then 1 hydrogen. So 1 hydrogen will be bonded by 1 sigma bond. So totally 1, 2, 3. So 3 sigma bond means it will be sp2 hybridization. So even here 1, 2, 3 sp2 hybridization. This carbon also will show 1, 2, 3. So it will be sp2 hybridization. So all the carbon atoms are showing sp2 hybridization. So now, so students, suppose a negative charge is present. How to find hybridization in that? So students, here what you have to do is, if negative charge is present, that should be considered as sigma, that should be considered as lone pair of electron. So here see the difference here. There is negative charge and there is double bond which is adjacent to this carbon. Here there is no double bond. So whenever double bond is present adjacent to that of the negative sign, it will be involved in resonance. So this negative charge will be involved in resonance. Therefore this negative charge will not take part in hybridization. So we should not count this negative sign. Why? Because it is involved in resonance, therefore it will not take part in hybridization. So whereas here it will take part in hybridization because there is no double bond here. So now this negative sign will be considered as lone pair of electron. So now count how many sigma bonds are present. To this carbon 1 sigma bond and here 2 hydrogen atoms are there. So 1 plus 2 it will be 3. 3 plus 1 lone pair of electron. So which will be 4. So 4 means it is sp3 hybridization. So this carbon will be showing sp3 hybridization. Whereas here 1 sigma bond and then 2 hydrogen atom means 2 sigma bond. 2 plus 1, 3. So here this is not considered as lone pair because it is involved in resonance. Therefore 1 plus 2 it is 3. If it is 3, then it is sp2 hybridization. So this carbon will be showing sp2 hybridization. Therefore you should remember, if negative sign is there, how to find hybridization. Is that clear? So now we will take some more example. So this is from the textbook what I have taken examples. So we will solve this so that you can understand it better. So CH3Cl, which is methyl chloride. So you can write the structure like this: CCl, hydrogen, hydrogen, hydrogen. So how many sigma bonds are present? 1, 2, 3, 4. So totally 4 sigma bonds are there. So if 4 sigma bonds are present, then this carbon will be sp3 hybridization. Then second example. So C double bond O. CO can be written as C double bond O. Then CH3 two times. So you can write here CH3. So I'll write it separately, CH3 and then one more CH3. H and H. So this is one CH3. So I'll just mark it like this. This is one CH3 and this is second CH3 which is attached to carbon. So now we will find hybridization of each carbon. So first we will find hybridization of this carbon. So this carbon has 1 sigma bond, 2 sigma bond and this is 3 sigma bond. So if it is 3 sigma bond, then this will be sp2 hybridization. And here this carbon 1, 2, 3, 4. So 4 sigma bond. So this will be showing sp3 hybridization. And this carbon also 1, 2, 3, 4. So this also will show sp3 hybridization. We'll solve third example now. Third one, CH3CN. So CN will be triple bond, CH3, C, H, H and H. So this is the example. So we have to find hybridization of this carbon and hybridization of this carbon. So first we will find hybridization of this carbon atom. So 1, 2, 3, 4. So there are 4 sigma bonds. If 4 sigma bonds are present, so this will be showing sp3 hybridization. And this carbon will be showing 1 and 2. So there are only 2 sigma bonds. Therefore, this will be showing sp hybridization. Is that clear, students? Next, last example, CO NH2 and then H. So we have to find hybridization of this carbon. So 1 sigma bond, 2 sigma bond and 3 sigma bond. So if 3 sigma bonds are present, it will be sp2 hybridization. So this carbon will be showing sp2 hybridization. So now we will solve the NEET question which I showed you at the beginning. So this is the question what I showed. The state of hybridization of carbon 2, carbon 3, carbon 5 and carbon 6. So carbon 2. So this is carbon 1, this is carbon 2. So what is the hybridization of this carbon? 1 sigma bond, 1 sigma bond. So 1 plus 1, there are 2 sigma bond. So if 2 sigma bonds are present, then this carbon will be sp hybridization. So sp hybridization, you check where it is present. So sp3. So this you can rule out. sp. So this one sp, sp. So out of 3 options, 1 will be the correct answer. Next we will go for C3. So this is C3. So 1 sigma bond, 2 sigma bond, 3 and 1 hydrogen atom. So totally there are 4 sigma bond. 4 sigma bond means it will be sp3 hybridization. So check, second should be sp3 hybridization. Here it is sp2. So this is ruled out. sp2 ruled out, sp3. So this will be the correct option. So by elimination method, within few seconds we can come to the conclusion that this is the correct answer. So students, is that clear? So this is how if a question is given, we can easily find out the hybridization of the carbon atom. So students, you can watch other videos if you are finding difficulty in electrochemistry or mole concept. I have already made videos on that. Even very important chapter, coordination chemistry. So coordination compounds. So you can watch even those videos. I have taught in a very simplest way, easiest method. So you can go through those videos. It will be very helpful to you. So students, you can also share these videos with your friends. So all the very best students. I'll see you in the next video.